Greg and welcome to Premier Solutions. In today's video, we're going to look at a geometric approach of carrying out the addition and subtraction of vectors. But before we start, please make sure that if you're new to my channel, you hit the subscribe button and turn on the notification bell so that you don't miss out on any new videos. Okay, so to start off, let's consider these 3 points, A, B, and C. Right? If we say AB plus BC, AB plus BC, we get AC, right? Which is this, and this is what we call the triangle law for vector addition. Alternatively, if we are to come up with a parallelogram, right? Let's say we extend this here, then extend this one here, right, such that this is point D, right? We know that AD is parallel and equal to BC, and as well DC is parallel and equal to AB, such that if AD is equal to BC, we can say that AB plus AD, right? AB plus AD will give us AC, right? And this is what we call the parallelogram law for vector addition. So more generally, we're just saying that addition of vectors can be carried out by simply considering the start point, right, to the end point by taking any root. So we can just add vectors from the start point to the end point in any root. So for example, we can say here, if we say AB plus BC plus CD plus DE plus EF will give us AF, right? This will give us AF. So here we've said AB plus BC plus CD plus DE, right, plus EF. This will be equal to AF, right? So this is for vector addition, right? So now let's attempt these questions, which requires to carry out addition and subtraction, right? So I erase this here. This. Okay, so for number 1, we're given the vectors R being 3, 1, 2, S being 2, 0, 3, then T being minus 1, minus 2, 0. Right. Question now says find is a single column vector, S minus T. So S minus T, we're saying 2, 0, 3. 2, 0, 3 minus T, which is minus 1, minus 2, 0. Right? And 2 minus minus 1, that's 2 plus the 1, which gives us a 3. And 0 minus minus 2, that's 0 plus 2, which gives us a 2. Then 3 minus 0, that's a 3. So this is S minus T. And then 3 times T minus 2R, we're saying 3 multiplied by T being minus 1, minus 2, 0, right? Minus 2 times R being 3, 1, 2. Like this. This will be what? 3 times minus 1 minus 2 times 3. That's minus 1 minus 6, which gives us minus 7. And then minus 2 minus 2 is minus 4. And 0 minus 2 times 2 is minus 4 as well. Right. Like that. So now we're just going to multiply the result by 3 to get minus 28 minus 12 minus 12. Right. So this will be the final result that we want. And then for part C, For part C, we have to calculate r plus 2s minus t. So we're saying r, which is 312, right, plus 2 times s being 203, minus t being minus 1 minus 20, like this. So we're saying that of course we can first of all simplify this if we decide so to do that. So 312 plus 406, right, then minus 1 minus 20. Alright, and then we're now saying 3 plus 4 plus 1, that's an 8. And 1 plus 0 plus 2, that's a 3. Then 2 plus 6 minus 0, that's an 8. So 8, 3, 8 will be the final result that we get for part C. So this was looking at number 1. Now we shall move on to look at number 2. Okay, so for number 2, we're given that vector OA is 3i minus 2j plus k. Then vector OB is 4i plus 4i plus j minus 2k. Right? So now question says find vectors OR and OQ such that for part A, R is the midpoint of AB. So if you come up with a quick sketch, we're saying that we've got if this is the origin O, and then this is OA, and this is OB. This would be our AB, right? And R needs to be the midpoint of AB. So if this is RD, right? And what else are we told? We are told that we've got these position vectors for A and B. So first of all, you can calculate vector AB, right? We're saying that OB minus OA, which is 4i plus j minus 2k minus 3i minus 2j plus k, right? So 4 minus 3, that's an I. Then j plus 2j, that's 3j. And 2k minus k, that's minus 3k. So this is our vector AB. So if R is to be the midpoint, it means that AR would be equal to half of AB, which would be, let me just say, 1 over 2i plus 3 over 2j minus 3 over 2k, like this. So this is AR, but we need OR. So for us to get OR, we say that AR could be given by AO plus OR, such that OR is given by AR minus AO, right? This is our OR. But we know that OA, right, this is the same as minus AO, like this, right? So this is the same as AR plus OA, right? So AR being half I plus 3 over 2j minus 3 over 2k, then plus OA, right, in brackets, then plus OA, which is 3i minus 2j, then plus k. We're saying that 3 plus 1 over 2, that's 7 over 2, so 7 over 2i, and then 3 over 2 minus 2, that's minus 1 over 2j, then minus 3 over 2 plus 1, that's minus 1 over 2k. So this would be OR, right? This vector OR Now we need to find OQ. So allow me to erase this here. So now for OQ, we are told that Q is the midpoint of RB, right? Okay. For RB, okay, A. Okay, so what have we gotten for ORB? So if Q is the midpoint of RB, Q like this is the midpoint of RB. In other words, we're simply saying that RB being half of AB, right? And our AB, we calculated it as it was OB minus OA, which was half of 1, then 3, then minus 2 minus 1 minus 3. So this is RB, right? Which implies that if Q has to be the midpoint of RB, then we're saying that RQ is equal to half of RB, like this. Then we're now saying half of this already is just more of like 1/4, because we're saying half of this. It's just 1/4 of 1, 3 minus 3. So this RQ, but we need OQ, right? So RQ, right, could be given by, or we could calculate QB. Yeah, QB is much easier to use. So if we calculate QB, but we know that QB and RQ are just the same. So QB is still 1/4 of 1, 3 minus 3, such that OQ, which we want, is given by OB, right? OB plus BQ, right? So OB, we've got 4, 1 minus 2, then plus BQ. BQ is just negative first, so I'd rather say minus 1/4 of 1, 3 minus 3. This would be 4 minus 1/4, that's 3 and 3/4, which is 15/4, right? Then 1 minus 3/4, that's 1/4, and then minus 2 plus 3/4, minus 2 plus 3/4, that's minus 1 1/4, which is minus 5/4. So this would be OQ. Okay. All right. So now let's move on to number 3. So erase this part here. Okay, so for number 3, the points P and Q have position vectors OP and OQ respectively. The point X lies on PQ such that PQ is 2/3, PX is 2/3 of PQ. Find the position vector of X, which is OX. So we know that OX would be given by, right, OX would be given by OP, if we say OP plus PX, right, and we know that OP is 2 minus 1 minus 8, then plus PX is 2/3 of PQ, right, PQ being PO plus OQ, or OQ minus OP. right? So OQ minus OP, that's 5I minus 2I to give us a 3, and then minus J minus J, that's a 0, and 4K minus 8, that's a 12, like this. So this we simplify, 2 minus 1 minus 8, plus, that's a 1, 2, 0, then 8. So if we add 2 plus 2, we get a 4, then minus 1 plus 0, that's minus 1, minus 8 plus 8, that's a 0. So minus 4, so 4 minus 1, 0 is the position vector of x, which is OX. So this was looking at how we carry out addition and subtraction of vectors taking a geometric approach. Please feel free to leave a comment, drop a like, and don't forget to subscribe. Thank you.